I wanted to acknowledge the people that have helped make this possible today, and wanted to thank GIFSAN, the Joint Institute of Food Safety and Applied Nutrition, as well as funding provided by the US FDA for making this webinar available to everyone. And the presentation by myself will be from the Tasmanian Institute of Agriculture. So the main objectives of today's program are to provide an overview of the functions and features of ComBase, and to demonstrate how to access ComBase data and use different tools to help manage food safety, including spoilage, although ComBase has predominantly information about the growth of pathogens, but we always welcome data around food spoilage. At the conclusion of the webinar, participants will have a basic understanding about how to navigate ComBase features, how to retrieve and interpret data records, how to estimate microbial kinetics with models and use modeling tools, and know the basics about how to donate data to ComBase. So I'd like to give you a brief history of ComBase to let you see or understand how we've gotten to where we are today. Launched about 18 years ago, ComBase is a collaboration between the University of Tasmania's Tasmania Institute of Agriculture and the U.S. Department of Agricultural Research Service. The Tasmanian Institute of Agriculture is currently ComBase's managing partner, meaning we're responsible for the day-to-day operations and implementation of the strategic plans. Now, the ComBase partners have changed over time. Beginning in 2000, when ComBase started, it included the UK Institute of Food Research, the USDA ARS, and the UK Food Standards Agency. In 2006, the University of Tasmania joined the consortium, and in 2010, the partners were IFR, USDA, and the University of Tasmania. As of April 2016, the partners are the University of Tasmania and the USDA. I'd like to mention that, importantly, behind the scenes, Mr. Daniel Marin, the ComBase technical manager, who is based in Madrid, helps us design and produce the ComBase database and the model interfaces. And Daniel's been with ComBase, I think, for about 15 years, so he's a really essential part of what we do. Also supporting ComBase are the generous sponsors who help sustain our core functions, which are currently Unilever, the Coca-Cola Company, and the American Frozen Food Institute. And we do hope that other organizations will also consider becoming ComBase sponsors. In November 2016, an advisory group was formed, and this group helps us develop both short and long-term strategies that increase the value of ComBase to the food community. The scientific group helps implement this strategy by providing advice about how to fill data gaps, develop new models and features, promote data donations, and also identify effective ways to network and train ComBase users. Now, we're always interested in expanding the skills and geographical representation of our scientific group, so please contact me at mark@combase.cc if you're interested in joining us. Now, before we take a look at the different features in ComBase, I'd like to briefly discuss several factors that make ComBase highly relevant today. As many of you know, there are numerous global food drivers that affect how food safety and hazard plans are designed and implemented, and how preventive controls are established to ensure food safety. Such preventive controls must be grounded in scientific evidence about how pathogens respond to food environments and food processing. And this is even more important when we consider the interconnectivity of global food supply chains and the need for efficient and transparent ways of sharing digital data, such as we see with the blockchain revolution. Increased emphasis on science-based evidence is further reflected in the Food Safety Modernization Act in the U.S., where food safety management is now considered a continuum from farm to fork and must be based on scientific evidence. And the urgency to implement better food safety systems is underscored by the recent and unfortunate outbreaks that we learn about, seems like on a weekly basis, involving ready-to-eat meats, fruits, and leafy vegetables. Now, predictive models can help us address these issues, but because they're efficient tools to manage food safety, but in the majority of cases, the models are buried in the scientific literature. And by that, what I mean is the models are of limited use to small and medium-sized companies that don't have the necessary internal technical support to translate equations into user-friendly interfaces, and that's what ComBase tries to do for the food community. And so now, let's explore ComBase, and we're going to start off with the home page. So ComBase currently has approximately 50,000 registered users, and these users can access about approximately 60,000 data records, which grows with more data donations, and also access to 34 predictive models. Now, the models, on the most part, are based on data in ComBase, and primarily on the growth of bacterial pathogens in microbiological broth. And so when you base a model on microbiological broth, they normally provide fail-safe predictions for pathogen growth. Now, on the right side of the home page, as you see here, you'll find a list of news and events. And these are typically news about upcoming food safety conferences and ComBase workshops. If you have anything you would like us to post that's relevant, please don't hesitate to send it. And you can send it to, again, mark@combase.cc. And below this is a newer section that we added to ComBase, which is about job opportunities that are relevant to the predictive microbiology community. And you can see here a job currently open with Unilever in the UK. And then below this are RSS feeds of the latest journal articles that we locate on predictive microbiology and risk assessment. Now, above the events section are links to ComBase Facebook, Twitter, and LinkedIn accounts. And then under these are buttons to translate portions of the home page into Japanese, Chinese, and Spanish. Now let's look at the ComBase team page just quickly. On this page, you will find the ComBase partners that I mentioned earlier, as well as the donors, our advisory group, and also the ComBase scientific group. On the contact page here is a list of persons trained to assist you with most technical questions. Now, the first email address here is contact@combase.cc. So that's the first point of contact if you'd like to do that, or you're welcome to contact the other organizations here. Most of these have had a long history with ComBase, and they include the Center for Food Safety and Innovation at the University of Tasmania, the U.S. Department of Agriculture, the Food Department in the University of Querétaro, Mexico, the Safety and Environmental Assurance Center in Unilever, the National Food Research Institute in Japan, and the Department of Food Science and Technology, Agricultural University of Athens in Greece. After you've logged in and registered, you can then access all of the other resources. And again, there's no fee to do this. So I've already pre-logged in prior to this webinar. So here, we'll start off and look at the browser. So the browser, as you can see, is at the top of the navigation pane. The browser allows you to search tens of thousands of data records that have been deposited in the ComBase. And you search the database by selecting specific search criteria. Now, I would like you to note that up here is a button that translates the majority of the text, not the numbers, but the text into Mandarin. Now, the first step you need to decide is whether you want to retrieve data for microbial responses or if you're interested in locating the sources of data. So you can click on either of these tabs to make that selection. But first, I want to demonstrate how to retrieve records for microbial responses. Next, we need to consider if we want to get records about static data, so this would be, for example, temperature, pH, or water activity, where the conditions are static, or it means that the person that collected the data didn't record changes in pH, temperature, and water activity during the incubation of a sample. So that contrasts what I've just described, which is dynamic data, which is data collected that shows how environmental conditions change over time. But for this example, we'll search the database for any static or dynamic record. Now, suppose you want to deposit your data into ComBase, but you want to wait until your manuscript has been accepted by a journal. In this case, we have a private section where your data can be archived while you wait for your paper to be published. And once it has been published, you can then make your data public. However, we want you to please note that if you haven't deposited data in the private section, then these cells here will not appear on this page at all. And if you need help at any point, you just click on this question mark in the upper right-hand corner. And you can also view some information here that we have in our help section about ComBase tutorials, about how to use the browser, and some other information. So now let's specify some search criteria. So we click this drop-down button, and you can see that we have 10 different criteria or fields, which include the organism, which can be a species or a group of organisms like lactic acid bacteria, a food category, which is broad categories of food, food name, a common name for a specific food type, and this is a feature we've added in the last couple of months. Conditions, which are characteristics of the food environment. Properties, which are properties or treatments of the inoculum, the bacterial or yeast inoculum. The temperature, the water activity or sodium chloride concentration, the pH, the author of the data record, and lastly, the record ID. So we can select all or any of these to do a search. For each of these criteria, such here we're looking at organism, you could select just one organism, or you could do multiple organisms, and you can do that for most of our search fields that we have here. So in this example, what I'd like to do is select 3 organisms for this example, and so we can scroll down and select, for example, E. coli. But if we think we know what's already there, we can type in, for example, Listeria and add that, and I can also type in, say, Salmonella and add these. So now we have 3 organisms. Now next, what we're going to do under food category is we're going to choose beef. Again, you can see there's not that many categories, and it's quite broad. And then we're going to select conditions, and I'm going to pass over food name. I'll come back to that later, but we're going to select conditions. And in this case, I'm interested in data about ground beef. So in our criteria that we have in the drop-down, I'll show you here, you can see we have cut, which correlates to minced, chopped, ground, that kind of the preparation. I'm not going to choose any properties. For temperature, I'm going to choose a range of 10 to 40 degrees. And so I have 2 choices. I can slide this up to 10 degrees if I wish, or I can come in here, type in 10.0, and then click somewhere outside the field. Now I have a range of 10 to 40. We're going to add another field here for sodium chloride, and I'm choosing a concentration of 0 to 3%. Now you'll see here it always defaults to water activity, but by clicking here on sodium chloride, I can then change 30 to 3. And so now I'm searching for any record that has that. Now what I want you to note is you see this box here which says include where unspecified, and that also shows up under pH. And what this means is if you click this box, it'll retrieve any record that meets all of the other search criteria but doesn't necessarily meet water activity, or in this case also pH. And the reason for that is some authors of records have not measured the pH in the food, for the food or the environment that they donated the data into ComBase. And so now what we do is we click search, and we see that we've retrieved 17 data records. Now for this example, I wanted to go back and show you maybe a more efficient way of retrieving these same 17 records, and that would have been to have this field that I mentioned for food type. So that's a very specific name for the food. And so to do that, I'm going to delete, you see the X button, I'm going to delete food category, I'm going to delete conditions, and here I'm going to select food name, and I'm going to type in ground beef. And then Let's do the same search now. Just want to correct this water activity. Salt concentration there and click search. And what you see is we were able to find the same 17 records by searching on this food name. And I mentioned earlier that this is a new feature that we've added to ComBase, and I think most of our users will find it's one of the biggest developments or most helpful developments we've had with ComBase, in that instead of searching through tens to hundreds of records under very broad categories, looking for a specific record on a food type, you can now type in cheese, ground beef, any particular name like that, and it will only find those records for that food type. Now, by selecting this drop-down menu, you can see that we can sort the records in different ways. We can sort them by organism, food category, temperature, pH, salt or water activity, author, ComBase ID, or the date that the information was added to ComBase. And we're also going to be adding that food name category as a sortable criteria in the next few weeks. So you can see that, and also I want to show you that if you click here on any of these, you can select up to 20 and then click export and then download those specific records. So they will be downloaded as a CSV file, and I'll give you an example of that in a moment. Now, if we want to know the source of these records, you might remember that I said earlier that instead of looking for specific records, we can look for the sources of information. By selecting source here and then clicking search, what we find is that these 17 records were donated by the USDA Agricultural Research Service. And we see that within ComBase, this source has donated 531 total records that we can access by clicking here, but you'll see below this it says 17 matching your search. So what you see in italics that I'll click on now identifies those records that match our search criteria. Now, the search results provide a snapshot of each record. So for example, you see we have the food category here. We have the food name, which is always next to the species name, but again, we're going to add it as a new sortable category down here in the near future. We also have the temperature, the water activity, pH, conditions, the number of times this record has been viewed, the number of times it's been downloaded, and the date that it was added. Now you see here it says not available, and the reason for that is this is a feature that we added last year in September, and so we only have that information available for any data that was donated after September of 2017. Now let's examine an individual record. In the upper right corner here, or right there in the center right, you can see the record ID. In the top section, we find the same information that we saw earlier when we were looking at the search results. However, below this, we see properties of the bacteria. We see the strains that are specified. We see a snapshot of the experimental details and the way that the authors measured the microbial growth or inactivation, any comments that were added, and then the same information that I described earlier. We can click here and select Open, for example, with Excel, and this is what it looks like when we export that file as a CSV file. So you see it doesn't contain all the depth of information that we see when we're using the actual interface. So I'll minimize that and go back to what we're viewing. Now, we can view the data, as you see here, in graphical form, or we can view it in tabular format by clicking here. So you can just cut and paste this data and put it right into a spreadsheet if you wish. When we go back to the graphical form, I want to show you how we can use some primary models to fit the data. So we can collect fit here, and we see options that show up. Now, these options that appear are selected by the algorithms to reflect what could possibly be used with the shape of the data or this particular data format that we have. So we see here that we have 5 options, and these are the Barani and Roberts complete model, the Barani and Roberts model with no lag, a trilinear model, a biphasic model, and a linear model. So I'm going to select the Barani and Roberts model, and now we see the output below. So it's a nice fit to the data. We see the R squared is 0.995. We see the standard error of the fit here. We see the predicted initial value, that's at T0. We see the predicted lag or shoulder if it's in an activation. We see the growth rate is 0.104, and that is log CFU per hour. And we see the predicted final value here, that's 9.491. Now, I want to also point out something that not everybody knows, is that you can move your mouse along this line, and you can see X and Y coordinates along the fitted line. Now, you might also be interested in knowing how these data, so if this is a data record that someone deposited, they might be interested, or you might be interested, knowing how it compares to one of the ComBase models. Now remember, the ComBase models are broth-based models. So what the algorithms in the background are doing is saying, do we have a model in ComBase predictor? We'll be looking at those a little bit later. Do we have a model for E. coli in broth that matches these conditions, so 15 degrees, and possibly matches water activity or pH, but it's focusing here on temperature. And so by selecting prediction here on the graph, we can see that yes, there is a model in ComBase that meets these criteria. Now, if there isn't a model that meets the criteria, this will be a grayed out box that you cannot select. So we're going to pick this here. And as we can see, the predicted growth rate, we'll move down here. So this is the prediction based on the broth model. Says the growth rate is 0.069 log CFU per hour, whereas the fit that we did to the data is 0.104 log CFU per hour. And so we can see that this broth model is certainly not a fail-safe or appropriate model to be used for the prediction of growth of E. coli in this particular ground beef sample, at least for these conditions of temperature, water, activity, and pH. Now, a helpful feature of the prediction is that you can modify the model input. So, for example, maybe you're asking a question about what would the conditions in the broth-based model be that would more closely match up with what we see here in the observed data. And so we can do that. For example, I could slide my physiological state, which is the lag phase, like that. I might change the temperature and then begin to tweak these so that they more closely approximate what we see here. And so, for example, we see that the temperature of 16.7 for the broth model more closely approximates what we see with the observation. Now, of course, we can also modify the pH. We could also modify the water activity and, again, achieve some similar fits. Now, you may have noticed that when I talked about lag phase, when we look here, it's typically stated as physiological state. And what that means is that's the physiological state of the organism, or as Professor Joseph Barani states, it is the amount of work the organism has to do internally, cellularly, to adjust to a new environment. So when you move it from one environment to another, there are some genetic metabolic changes that need to occur so that it can grow in this new environment, and that's what we call the lag time. Now, this particular value is based upon the lag parameter in the Barani and Roberts model. And it can have a value of 0 to 1. And if it is 0, as you'll see here, the lag phase is infinite. If it is 1, there is no lag phase. And in general, because lag time is very difficult to predict unless you have a lot of data to support it, we recommend that you set this value to 1 in most cases so that you get a fail-safe prediction. Now, I'd also like to show you the example of a dynamic record, and to do that, I need to go back to the results. And in the results here, one more step back, I'm going to select, go back to responses, and I'm going to select dynamic here. And I'm also going to delete ground beef because the dynamic model I want to show you is located in another category of food. So for example, here we see E. coli growth in a type of cheese. And here you can see the temperature profile here in red. So you can see the authors also measured the pH as this particular cheese product was ripening. And up here we see water activity, which was also measured. So this is what we refer to as dynamic environmental data. So this concludes what I wanted to present to you about the database. And if you have any questions, of course, please don't hesitate to ask at the end of the webinar or contact me later at mark@combase.cc. So now let's visit the ComBase predictor. So I'm going to select it here. And we see that the ComBase predictor contains, as I mentioned earlier, broth-based models. We have 25 for growth. We have 7 for thermal inactivation, and we have 2 for non-thermal inactivation. Now, if you're interested in accessing food-based models, then if I just take you down here to other resources, please visit these links. So here we have CB Premium, which is a new product from the University of Tasmania that is entirely food-based models. In Denmark, Paul Dalgaard hosts the Seafood Safety and Spoilage Predictor, USDA Pathogen Modeling Program, and obviously there's quite a few more here that you can access. So do that if you're mostly interested in a model for a specific type of food. Now, for each growth model, you can set the initial level or lag phase, temperature, pH, and water activity, like I showed you when we were looking at an individual record. And the predicted growth rate and the doubling time, which is just a conversion of that into this value, are shown here. Also, I wanted to point out, and again, this is something that not a lot of us know about, but if you right-click on the graph, you can insert a horizontal crosshair, or you can put a vertical crossbar in here, and that might be useful if you're trying to locate a particular intersection of time and microbial growth. Now, you can also make predictions for dynamic temperature conditions, such as those that occur when a food is in transport or storage. And for that example, I'm just going to bounce over here to a temperature profile for you. So I've got a sample dynamic temperature profile that I'll copy and paste. So it's that simple to just paste it into these cells like that. And so what you can see here is that we've got a dynamic temperature and a predicted growth, in this case of Aeromonas hydrophila. And so that's an example of a dynamic temperature profile. You can also add up to 4 different model scenarios. So we've made the interface capable of looking at 4 different predictions at the same time on a graph. So for example, you might be interested in understanding how, I'll just change it to Bacillus cereus, how Bacillus cereus grows under different environmental conditions. So it could be different pH values here. So it's the same organism, just different pH values. Or you might be interested in saying, okay, I have a particular food environment, and what I'm interested in knowing is how would some potential hazards, how would they behave in this food under the same conditions? So we could set these inputs all to the same condition, and now we're able over here to visualize those growth profiles. Now, you can also add your data to this plot. So you'll see here it says plot custom point. So if you have data that you would like to compare to one of the ComBase model predictions, you just cut and paste it here. And now you see those data points appear on the plot that I showed you earlier. In addition, you can examine the uncertainty of the model. So this is for those that are fairly proficient in statistics. Now, going back to predictions, We can look at, as I mentioned earlier, we have 7 thermal inactivation models here, and we have 2 non-thermal inactivation models. You can see that the interfaces they function in a similar way as the growth models, with the exception that D value is shown here rather than the doubling time. So with that, I'd like to now show you a little bit about the ComBase food models. And so you can see that we have 2 models. So again, ComBase focuses mostly on data, that's the database, and broth-based models. The 2 models that we have for foods are salmonella and egg, and we have the perfringens predictor. Now the user interface for salmonella in egg is almost identical to what we've looked at before for growth models. However, the perfringens predictor is quite different. This predictor was designed as a decision support tool for a specific food safety issue that's faced by processors of meat, cooked meat, and cooked poultry. And I would urge you to go and visit if you want to learn more about the application of this model that is permitted by FSIS. Look at this document, many times referred to as Appendix B, which is the FSIS Compliance Guidelines for the Stabilization of Fully and Partially Heat-Treated, Ready-to-Eat, Not Ready-to-Eat Meat and Poultry Products. So that'll give you more background information. So to use this model, you select whether you've got a cured or an uncured product. You then enter a pH within this range that you see here. You enter a salt concentration here, and then we'll go back to our profiles. We'll put a sample of a cooling profile here, and then what we do is we click Predict. So again, this tool is used by these industries when there is a deviation in the way that they cool the product. So if it's not cooled within the particular time temperatures that have been established by FSIS, then they're allowed to use this model to see what the predicted growth could have been under a deviation in cooling temperature. And if we put our mouse up here, we see that the predicted growth was 0.65. And as long as this value is less than 1, then the company is allowed to sell this product. So you can see that this is quite a handy tool for industries that have these deviations. Now, with that, let's look at DMFit. So DMFit is a tool that fits the model to the primary data, like I showed you a bit earlier when we were looking at individual records. And it can do this for either microbial growth or inactivation. So again, I'm just going to take some sample data here, and copy it, and paste it in this profile. So this could be data that you've generated in your laboratory. And now what you'd like to do is see what the growth rate, the lag phase, and the maximum population density would be. And much like we looked at the previous records, you can see that you've got different options of models that you could fit to the data. For example, that's what a trilinear model fit would look like, but we're going back now to the Barani-Roberts. So you've got your R-squared, your standard error fit, and as we saw before, the initial predicted level, the lag time, the maximum growth rate, and the predicted final level that we see up here in stationary phase. Now, you can also, as you see here, download DMFit as an Excel file. It comes with a lot of helpful macros, and this is what I use routinely. I don't typically use the online version, but I just want to caution you that if you're not well versed in how to use the Excel macros, it can be a little bit of a learning curve, and we're always there to help you if you would like to use it. Now, let's look at resources. Under resources are the same resources I showed you earlier, other websites that host different types of predictive models. And then in the health section, here we have in-depth information about ComBase Predictor. So it really goes into a lot of detail about how it was developed, assumptions, and I encourage everyone to read that if you're using the predictors, as well as the same type of information or details for perfringens predictor, the salmonella and liquid egg model, DMFit, how to donate data, frequently asked questions, and links to ComBase YouTube tutorials. And we're adding new tutorials on a regular basis, so you'll notice that I'll occasionally send out emails to registered ComBase users to learn more about those. Now, going back to data donations, we can access data donations also on the home page. I just wanted to emphasize that data is the core of ComBase and what we need more of, because the main value of ComBase is its data. And even though we've got approximately 60,000 data records, we need much more data so that we can better assist food companies and food managers and researchers and help them solve important food safety and quality problems. And as you know, the scenarios change over time, the types of foods change, the pathogens might change, so new data is always welcome and needed. Now, as a ComBase user, we hope that you'll donate your data and encourage others to do the same. And your donations benefit the global food safety community, including yourself, because as I showed you earlier, you can track how many times your data have been viewed and downloaded by others. Now, in this section, we explain how to donate data, including 2 useful YouTube videos about how to format the data in an Excel template, and we give you samples of Excel templates that help you out. And again, always contact us here at data@combase.cc for more support. So now I'd like to return back to the slides just for a few minutes. And go back to that previous one that we were looking at. Okay. You might be interested in future enhancements that are underway. Now, these include a new data wizard to make it easier for you to donate data. That should be coming out in a couple of months. We will also have a new feature that will help you overlay ComBase data on top of models. And we're expanding the upper temperature range for Bacillus cereus and Staph aureus. So currently, they don't go much above 35 degrees, whereas in the food industry, they cook products and cool them down, and they want to be able to predict what happens at higher temperatures. So we have a project underway to do that. And finally, we have a project that's underway to integrate ComBase with temperature sensors. And in this project, we want to make ComBase models and data more accessible to external software applications. It essentially involves Daniel Marin, our technical manager, developing programming code that will link ComBase to external applications, and you can see in this case a sensor, and these are referred to as APIs, or Application Program Interface. And this exciting application should make it possible to monitor real-time food safety and quality information while products are in commerce, including during transportation. And so with that, that concludes my webinar today, just providing you with an overview of ComBase. And thank you for your time and look forward to your questions.
Mark, thank you so much. That was absolutely fantastic. Thank you. For people who are connected to the webinar, we'd love to take your questions. We don't have any yet. To get to the Q&A box, you may have to exit from full screen to begin by mousing to the top of your screen, exiting full screen, and getting to the Q&A section. You can also post your questions in chat, and I can pose those forward. We want to mention that for the data donation tool that is coming, we will plan on doing a webinar to talk more about that tool. Mark, is that expected later this year?
Yes, we're going through beta testing at the moment, and we're expecting to have it available in probably the latter part of next month in August.
Great. I have a question for you. So what interests me is I'm a programmer. We often are using APIs to databases to do more with the databases that are available. You mentioned more up-to-date and more timely data in ComBase. Are you seeing the API be a tool in which data gets inserted into the database more frequently?
Well, at the moment, what we're envisioning is that the new data wizard will help accelerate that. Just to give you just a brief perspective on that, is that we as far as data collection, what we have found to be the most effective is our data team locates particular pathogen food combinations and we contact authors. We found that's the most effective way of getting an author to engage with us, and then we help them donate their data. So while the data wizard, we hope to make it even easier to do that, we typically rely on that contact. In the case of an API, what we're envisioning is that API is going to, so for example, if you have a temperature sensor that is collecting, of course, time and temperature data, it will send a call that will go out to ComBase. So that would say, this is the temperature of my product. It would go out to ComBase. That temperature then serves as an input into whichever ComBase model has been selected by the user, and then returns to the interface, that is the sensor interface, will return what that growth rate would be. And so what we would see is, as the product is moving through commerce, several companies currently have real time where you can go onto a web interface, you can see your product moving, and you see your time temperature profile. And what the user would be able to do is overlay the predicted growth of a spoilage or a pathogen organism or a prediction about shelf life.
Great. I envision us starting to implement something like that API into tools like iRisk, and getting risk modeling to be easier to do and easier to create models on the fly and faster in the future.
That sounds exciting. We'd be very happy to work with you on that too.
Yeah, absolutely. So we do have a question. How do you vet donated data, and will that change with the new tool as well?
Well, in fact, the new tool is going to help us do a better job of vetting the data. So the way that we get this, this is a common question and a good one. The way that we perform quality control on data is think of it similar to a journal article. The journal article, there's a peer review process. There's an examination, of the data that have been presented, and then a decision whether or not it's acceptable for publication. Now, in the majority of cases, reviewers of journal articles don't look at the raw data. They're only looking at, outputs of the raw data, like predicting growth rates and that type of thing. So what we do when we receive the raw data, we format it. We perform some quality control checks. For example, the person may have mistyped a log CFU and put in log 24 instead of log 2.4, and we have macros that catch that. And then once we formatted the data, we go back to the donor of the data. We show them how we formatted. We also typically have secondary plots. So if, let's say, for example, data has been collected about the growth of an organism over different temperature conditions, we'll do a secondary plot to be sure that, as we would expect, growth rate should increase with temperature. And so we present all of that information back to the data donor and ask them if they agree that the data are accurate and we have the permission to donate it. So, we can't say that it's 100% accurate all the time, nor can we say that every journal article is 100% accurate. I can tell you from real experience is that we probably can say that we add value onto journal articles because it's not uncommon for us to find some errors in the raw data, and we can then make that information available back to the author, and then we can also make those corrections in the data that are deposited in the ComBase. But the new data tool, the wizard, is going to have more built-in quality control checks that will help us do that more efficiently.
Great, thank you. I have another question. Is in the presented data on E. coli and ground beef, what is the difference between the prediction option versus the growth kinetics given by the Bernier-Roberts model?
Okay, so would you like me to go back to that slide? We'll just talk about it.
I think that would be helpful.
Okay. Let me go back to that slide.
While you're doing that, I can comment on another question, which is how can I obtain a copy of the presentation? So we will be following up after this presentation or this webinar with files including the presentation. We also have recorded today's presentation and we'll be hosting it on YouTube. I'd like to have everyone go to YouTube and search ComBase. You'll see that there is a ComBase channel that Mark has put together, which includes some information on ComBase as well as where we will host the webinar once we've processed and got it published.
Okay.
All right, back to you, Mark.
Yeah, well, thank you for helping fill in some time too while I'm just adding these other categories for we can take a quick look. Okay, let's see. I'll put in also salt concentration that we spoke about earlier, and that should be enough, I think. Let's see. Okay, so I'll just go to the record that we were looking at, and the question was, would you please read that back again?
Sure, let me pull it up. The question was, in the presented data on E. coli and ground beef, what is the difference between the prediction option versus the growth kinetics given by Bernie and Roberts' model?
Okay, so when we have the data record, so these are the raw data, we have an option of fitting it and or comparing the fit to the prediction that's based on the broth-based model. So if I click fit, I can, for example, I can choose this model, Iberani, the complete model. I can choose a no-lag model. I can choose a trilinear model. I can choose a biphasic model, a linear model, and so on. So when you select a model, obviously, evaluating the R-squared value can tell you which one has the best fit. So now I see what, for example, here, my growth rate is 0.104 log CFU per hour. Now, if you also want to see how does this observed growth compare to one of the ComBase models, if these criteria here match one of our broth-based models, you'll have the option, when you click this, of inputting it or laying it on top of the graph. And that's what we see here. So what we see is that obviously the broth-based model says there's a much longer lag phase than we would see that the authors saw when they inoculated ground beef. And that's not unusual because in general, there's a shorter lag phase in a food than there is in a broth. I don't know the reason why, but that's not an uncommon observation. So, as I was saying earlier, what we could do is you could adjust that lag phase and say, okay, it looks a little bit more now like what the observed data, but you see still that the growth rate is 0.069 versus 0.104. So still it says that the growth rate is less. And so again, you can make some adjustments with temperature to try to get them closer, but that is essentially the difference. Now, when we did the fit, we had different options for the fit. We don't have any options for the model because it's the model that's in ComBase. It's one of these ComBase predictor models that matches E. coli under these conditions. So I hope I've answered the question.
Thanks, Mark. That's actually all of the questions that we have at this time. I want to remind everyone that Mark did provide his contact information. Feel free if you have any questions. I'm sure Mark is available to reply. Once again, this has been hosted by the Joint Institute for Food Safety and Applied Nutrition. We thank everyone for joining today. We will be making the presentation and the recording available over the next week. Please check the ComBase YouTube channel or the GISTAN training YouTube channel to look for that video. And if you have any questions, please let us know or follow up afterwards. Thanks everyone for joining today. Mark, thank you for a fantastic presentation and for your time today.
Thanks everyone at GISTAN. Thank you.
Great. All right, thanks everyone. Everyone have a great day.